All right, we're going to talk about the electronic geometry. We've been talking about the molecular geometry and we've been predicting the geometry together. Now we're going to use that to talk about the electronic geometry, but it's pretty much the same thing, really similar, okay? All right, so for molecular geometry, start with the carbon dioxide. You know this is linear. How do you know? What are you looking at so you know that carbon dioxide is linear? You know what I'm saying? What makes you think that this guy is linear? Well, you look at the atoms, right? So two non-central, that's linear. Okay? Now, the electronic geometry, we look at the electron around the central atom. Okay? Now we look at electron around central atom. I go back right here. So right now, so when you're considering the molecular geometry, you look at how many you considering the how many non-central atoms are there, right? But electronic geometry will consider the electrons. We say electron groups around the central atom. Right now, this carbon here got two electron groups. So we have this on the left side, on the right side, and which the electronic geometry is also a linear. Okay, also a linear. All right, now next one. So if you don't get what I'm saying yet, don't worry. So you'll get it. All right, start with the molecular geometry of aluminum chloride. So molecular geometry, molecules. So we look at atoms, right? Look at the non-central atoms around aluminum. So it looks something like that. So we call this geometry a trigonal planar. Now, electronic geometry, we look at the electrons arrangement around central atom. So just ignore the chlorine, just electron arrangement. So aluminum here, so we got electron group point to the top, to the left, to the right. It's also trigonal planar. They are all on the same plane. All right. Lastly, all right, try one more time. So molecular geometry of ozone, all right, of ozone. Look at atom. We just look at atom. So look like that. What do we call that? A bent. Yep. So we call this a bent. All right. Now electronic geometry. So look at the arrangement of electrons around the central atom. So what does it look like? Electron. We have electron here, here, and here. One more time. Here, here, and here. So it looks like that, right? What do we call this geometry? A trigonal planar. Now it's different. Molecular geometry, the molecular geometry and the electronic geometry could be different. Depends on the arrangement of an atoms around central atom or the electrons around the central atom. All right. All right. Try one more time. So we have the structure of ammonia. Okay. So molecular geometry first. So we look at just the non-central atom. Ignore the electron. Just the non-central. So it looks something like this. We have the same plane pointing toward you. The other hydrogen point away from you. All right. So this one we call it a trigonal pyramidal. Look like a pyramid. Okay. Now the electronic geometry. Just look at the arrangement of electrons around a central atom. So we have point up and then up and down, down and down. So it looks something like this. What does it look like? That's a tetrahedral. There are 4 groups. See that? This is a tetrahedral. Right. All right. One more time. So water molecule. Start with the molecular geometry. Look at just the hydrogen. So atoms. Look at the atom. So that's a bent structure. Now the electronic geometry. Look at the electrons arrangement around this oxygen. So it looks more like a tetrahedral. So there are 4 groups total. That's a tetrahedral. Okay. So if some of you can't really see it, so this is on the these two on the same plane. If I move it a little, so it look like a tetrahedral. All right. Okay. All right. Let's try on your own, right here. Okay. So it's gonna be could be a little bit difficult at the beginning, but once you get a hang of it, it's easy. It's really easy. Okay. All right. Once you do this, check with me on the next video.